Hi, my name is Jared Bauk. I am a student in astronomy and Japanese in IGP. I studied at Yamaguchi University last year in Yamaguchi Prefecture, Japan. And my research project, my internship was working with Professor Fujisawa and Professor Motogi at Yamaguchi University's Astrophysics Lab to study a periodic methanol maser. And so we're going to talk a little bit about that today. So what a maser is, it's pretty similar to a laser, which I'm sure most of you have heard of. So laser is an acronym. It stands for light amplification by simulation of emitted radiation. Basically what it means is you start out with a little bit of light and you amplify it to make like a really strong beam or a really strong signal. A maser is pretty much the same thing, except for instead of working with visible light like a laser does, the M in maser stands for microwave. So instead of working with visible light here, we're working with microwaves. Often this kind of bleeds into the radio area of electromagnetic radiation. So my project was using Yamaguchi University's 32-meter radio telescope to study this object in a distant dust cloud. Now, IRAS 22198 was our target, and this is actually a young stellar object, so it's a star that's in the middle of formation. Now, this star doesn't have a lot of accretion going on, but it does have a surrounding dust disk, and that's where these maser signals actually come from. So as these stars emit radiation, it interacts with their surrounding dust, and we get these really strong signals coming from the gas around the star as a result. And so there have been many studies of this object over the years. We're actually monitoring it. It's one of the shortest variable sources that we've seen to date. It has a period of only 34 days, which means that just about every 2 weeks we start to see the signal from this region of space. And it gets really strong over the course of about 12 days, and then it starts to fade again to the point where we can barely even see it. So this is a really interesting object because it has such a quick change in the strength of the signal. And so I was working with the lovely professors at Yamaguchi University to measure the radio flux of this object over the course of 2 weeks. Here's a picture of the 32-meter telescope, just a little bit of a way outside the university. And like I mentioned, we had 2 weeks of observations for this project. And you can see that we get a pretty similar result. We start out with a very low signal, very weak signal coming from the stellar object. And over just a couple days, it starts to get really strong. We get a lovely Gaussian curve, and then we drop back down to barely detectable, below our noise limits of a signal. And so my research was able to kind of add to this really long survey that's been taken of this object IRAS 22198, and it supports the currently held theory that this object is a binary system. So as these two stellar objects interact with each other and the gas around them, you get these periodic maser sources that we can easily detect with our telescopes here on Earth. If you'd like to know more, please reach out or come meet me at Summit, and I'll be happy to chat. Thank you.